On page 147, question number 8, review question for section 3.5, we have a skier that is accelerating downhill and then approaches a flat segment in which friction is going to cause him to slow down. In order to answer this question, we're going to establish that the directions, downhill and right, are positive. In part A, we're going to determine the final speed of the skier after the 8.2 seconds that he travels downhill. From the question, we know that the net force acting on the skier is positive 92 newtons. That is 92 newtons downhill. In this question, we didn't have to list all of the forces acting on the object because the question already gave us the net force, or the sum of all of those forces. So we can go to the next step, which is to replace F net with the expression MA. So MA is equal to plus 92 newtons. We can use algebra to rearrange this. The mass of the skier from the question is 68 kilograms. And if we punch this into our calculator, we end up with an acceleration of positive 1.4 meters per second squared. Once you determine the acceleration, you have enough information to calculate any kinematics quantity. So in this situation, we want to determine the final speed, assuming this skier started from rest, traveled for 8.2 seconds with an acceleration of positive 1.4 meters per second squared. If we look at the variables that are given and the variables required, this leads us to equation number 2 from kinematics. And we're going to sub and solve to determine the final velocity. So the final velocity is equal to 0 plus 1.4 meters per second squared times 8.2 seconds. If we punch this into our calculators, we end up with positive 11 meters per second. So we can say the final velocity of the skier is 11 meters per second downhill. In part B, the skier leaves the bottom of the hill with a speed of 11 meters per second, as we've just calculated, and then starts to slow down for a time of 3.5 seconds. And our job is to determine the speed it will reach after 3.5 seconds. The first thing we need to do is determine the acceleration of the skier while it is decelerating. In order to do so, let's follow the same 2 steps. The first step is to list all the forces acting on the object. In this case, we have 1, and it's in the backwards direction, and it's the force of friction acting on this object. The second step is to replace the expression F net with the equation MA. So we know that MA is equal to negative force of friction. If we rearrange this equation, we get acceleration is equal to negative the force of friction divided by the mass. And we can go ahead and sub and solve. That's negative 22 newtons divided by a mass of 68 kilograms. If you punch this into your calculators, you should get an acceleration of negative 0.32 meters per second squared. So this negative acceleration implies that the object is slowing down. In order to find the final velocity, v2, of this object, assuming it started with a speed of positive 11 meters per second and will be decelerating at a rate of negative 0.32 meters per second squared, over a time of 3.5 seconds, we can use kinematics equation number 2 to determine the final speed. So it is plus 11 meters per second plus negative 0.32 meters per second squared times 3.5 seconds. If you punch this into your calculator, you'll end up with positive 10 meters per second. So we can say that the skier's final velocity after the 3.5 seconds is 10 meters per second to the right. In part C of this problem, we want to determine the total distance traveled by the skier. So what we need to do is calculate how far he travels downhill and how far he travels along the flat portion. We know that while traveling downhill, his acceleration is positive 1.4 meters per second. He starts off with a speed of 0 and ends up with a speed of 11 meters per second over a time of 8.2 seconds. And we know that during the flat portion, he's decelerating at a rate of negative 0.32 meters per second. Meters per second squared, rather. Initial speed of positive 11 meters per second. A final speed of 10 meters per second over an elapsed time of 3.5 seconds. So let's look at the downhill component first. Collect all of the kinematics terms and we'll use a kinematics equation. So to review, we have an initial speed of 0, acceleration of positive 1.4, delta t is 8.2 seconds, and we need to find delta d. For this, we can use equation number 3. And we know that this can be simplified because v1 is 0. So delta d is going to be equal to 1/2 a delta t squared. And we can go right ahead and sub and solve. So positive 1.4 and a time of 8.2 seconds. Square it. Punch it into your calculator, and you should end up with 47 meters, positive 47 meters. Along the flat component, the initial speed is 11 plus 11. The acceleration is negative 0.32 meters per second squared. The time is 3.5 seconds. And we want to find delta D. Again, we can use the third equation. This time, the equation doesn't simplify, so we have to sub in all of the variables. So it's plus 11 meters per second times 3.5 seconds plus 1/2 negative 0.32 meters per second squared times a time of 3.5 seconds and square it. So this is a pretty big equation. Make sure you double check it if you have time. If you punch this into your calculator, you should end up with positive 40 meters. So the total distance would be equivalent to 47 meters plus 40 meters. If you add these two together, you end up with 87 meters.